Hey.
Hello.
I'm not sure if we can expect a lot of people from the US now. It's a bit late.
I think sometimes
Yeah.
Devin and Craig show up, but I'm not sure. They were here last week.
Hmm.
Or at least Devin was.
Can give it 2 more minutes and see. I guess it just does then. I'll go over the agenda. I'm not sure if any manager is joining, but there is an ask from Steve for people to give examples of alert storms where you're being paged in a lot of times for the same problem. He's trying to look into ways to reduce the amount of alerts when something goes wrong, and there is some cool diagrams and so info in the issue that is worth looking at. And next I'll go over the Vault demo. And since this is recorded, we'll then share with the other time zones. I'll share my screen. Can you all see? All right.
Maybe a bit larger.
Good.
Well, yeah.
All right. So this is what we're going to cover as an overview. Vault is currently deployed in the pre-environment, and this is the external URL that you can use to access today. Well, not to log in yet because we are still waiting on IT to get some permissions on to access Google Groups so that we can integrate policies for everyone. And this is the internal URL where we'll be connecting to over most services. And going over the cluster setup quickly, it does use the official Helm shard from HashiCorp. There is links on most of these topics where you can either look at code or more details. And going over the high availability setup that we currently have, there is 5 pods deployed in the stateful set. It does use multi-zone, so there is 2 pods per zone, the preference, and they can shift depending on if there is a zone of failure or not. The disks are regional, so we don't specifically are bound to a zone because of the data. For storage, it does use Raft, also for Quorum, so everything is built into one. Hey, Graham. Do you want me to go back? We just started like 1 minute ago, and I was just starting to talk about the Vault setup.
I think that's okay because I'm pretty sure it from what I've seen, it looks pretty standard. Nothing.
Okay. Yeah.
Yeah.
Just quick highlight also, it does use the official Helm shard from HashiCorp. For high availability, we have a stateful set with 5 pods. It runs 2 per zone by default, well, except one zone is always getting 1. And this is for quorum reasons based on how Raft calculates the leader. We use regional disks, so we are not bound to a zone for storage. And as I said before, it uses Raft for storage and quorum, so everything is built into one. We have snapshots, backups that we push to a bucket in GCS, and we've tested recovery from it, and all works well. In terms of security, it does use KMS from GCP for auto unsealing. So this means that even if we have data that is stored in disk, exposed somewhere publicly, it doesn't matter because data is always encrypted in a like a combined way. We need KMS from GCP and plus other tokens to actually unseal the data so that we can access it. And there is some details in this link here on how we can see how Shamir keys works. We don't have a root token, so it's not possible to have like an admin token for everything. We remove it after bootstrapping. We do have recovery keys that are stored in 1Password that we can use to recover from snapshots. In case there is a full region outage, we can easily take data from GCS and bootstrap the service somewhere else.
But the recovery key is mostly, recovery key is just to get a root token again. Like if we, disaster scenario, you use the recovery keys to get a root token, and you can use the root token to restore snapshot if you want. But the restoring from scratch is just you initialize again, and so you get a new root token from that, and then you force a snapshot restore, which will put your data back, and you are good to go. Pretty much.
Thanks. So the general way the cluster is set up is deployed by Helm in Kubernetes, but all the configuration comes from Terraform. So run everything from roles, policies, and everything is in an environment in config management, and there is a link for the folder. In terms of secret structure, we only have 2 key value backends for now to mimic what we currently have with GKMS and other stuff that we are using in different tools. So we have one for CI, and we are modeling it after basically host name. So this is going to be either gitlab.com or ops.gitlab.net, and then the repo and the environment. So the roles are being scoped in this way so that we can, for now, scope it to a specific repo and a specific environment.
Do we just quickly on this, like often we have the same secret, like to me, I'm not sure. I'm not sure. I'm assuming this is done like this, as you said, more about role-based access permissions, but like, are we going to have this situation where you have 2 secrets that are the same thing, but have to go in different parts? Like to me, that seems more complicated, if you know what I mean. Is this the only way we can kind of, okay.
You can set the secret at the repo level as well. Like you can have ci/gitlab.com/repo/your secret, and those secrets at that level, only that level and not subdirectories, are accessible to all environments.
I mean,
so
this is not. This can be changed, obviously, and we can figure it out. All I'm thinking about is we don't want a situation where it's like, oh, here's a password, or we want to try and avoid a situation where it's like, here's a password, but you actually have to update it 3 times in Vault because different things are using what is the same password. So, but yeah, I appreciate that like namespacing it that way means you can say this CI job can access that, or this Kubernetes cluster. So I don't know, play around with that. Think about how you can kind of, if you can get it to the point where even if it's just like, here is the secrets, like a production, here's the secret, but we can like, I don't know if we can do roles so that we can have CI and jobs and Kubernetes clusters accessing the one secret. Because I think a big thing here is, obviously for the whole point, part of the big work on this project is a single source for secrets, right? So we want to try and push that as much as possible where we can with the opportunities that are made available to us. It could also be, I think you probably need to we need to document and investigate the variables we use in general. Like there are some that are just used for CI, and there are some that I use. See, it's tricky because it's almost like you want to define. Sorry.
I totally agree. And the structure that we have now is like the basic of the basics.
Sure.
We do have shared folders in these that they can be accessed.
Sure.
Like for example, the repo level can access a shared folder that all environments can access and stuff like that. And it's easy to manipulate this in any way that we want.
Yeah, exactly. Yeah. Okay, cool.
Just we didn't want to go full on into trying to solve all the problems that we have in trying to scope specific secrets for now. And then just like to try to mirror what's already in place so that we also don't put any limitations on integration and stuff like that.
Sure.
Yeah, for Kubernetes, same thing, cluster, namespace, app, and the app will be bound to a service account, and that service account then is bound to a role, and that role can only access this path and so on. And same logic, there is shared folders. You can share a folder across the whole cluster, the whole namespace, and so on. In terms of authentication methods, at the moment we are leveraging Google for integration with GCP. It uses OIDC, and it also uses JWT depending on what kind of things you're doing. Kubernetes, we have authentication with the cluster based on service accounts and native Kubernetes authentication, and with GitLab using JWT, and this is how we integrate with CI jobs. And then April, which is kind of like token based, and we only use it for provisioning at the moment. We don't use it for anything else. And next I'll go over some examples, merge requests where, for example, this is not a merge request, but this is how it generally works in CI with a native integration using the secrets feature. So basically, you just provide a variable and then you specify which path in Vault it uses and which field to grab, and this will basically inject the secret in a CI variable, like if you're using the variables in the CI job. And this is pretty straightforward and is like the simplest one. And this currently works for gitlab.com and ops that we have integrated with Vault. And I'll go in a bit over how it works, but not into much detail. And next, Terraform, on all of these methods, they will use, for example, for CI, it will use the GitLab authentication backend. Then for Terraform, it will also use it, just it depends on the way that we are authenticating it. If we go here quickly to the providers, we can see that we have dynamic of login, and this is where we configure. So these settings here, these will be provided by CI, and these Vault JWT and the auth role, they come from the job itself. If we go over, it's gonna be hard to explain here.
And then in Terraform, they just become local variables, or
yeah,
or from the the Vault is a provider, right? Like, so, and then we just reference the provider and
the variables here. Yeah, yeah. So this is templated with the JSON edited stuff that we have, and here will just be like, for example, the auth role will be named after the repo, and then just read only, read write token, and so on. And this is the CI JWT token. So we are using the native GitLab CI token to authenticate with Vault. And just to show how it looks on the other side, environment, Vault, roles, GitLab. This is how Vault grants the role to the job or not, based on bound claims. So here we have a project ID, which we configured before, and there is a bunch of other parameters that we can set on. For example, we only allow it to assume this role if it's coming from this project ID and if the reference is protected. In this case, if it's running in the master branch or main branch, and then we give it these policies, and the policies is what is currently scoping what kind of path it can access in the key value backend. And we have configuration here. Here we set it for config management, project ID 138. So, and the way that we validate if this is this instance of GitLab it uses a JWKS endpoint in that instance to validate that actually is that GitLab instance that is generating these tokens, so that we can authenticate both ways. And once the provider is authenticated, then we can just grab secrets from there. In this case, we are grabbing secrets to configure Vault itself. So Vault uses Vault to configure itself. And then moving on to Helm or Tanka, anything Kubernetes. This is a bit generic in the way that it works for anything. Here we're just explaining how it would work for Helm or Tanka. We're just installing Vault and then just generating the token in the same way that Terraform was obtaining its credentials, which is using the Vault authentication path it's going to use, which is the GitLab authentication backend, which role, and then the CI job. And this allows us then to execute anything with Vault that role allows. For Helm files here, we are using the native integration, which is just a reference Vault and then the path of the secret. So this will expand the secret and just apply it here instead of what we were doing before, which was executing gcloud. So instead of gcloud now, these Helm files library will execute Vault API calls and get secrets for us automatically.
One thing about this one is it's not documented in the Helm file documentation. I had to find that in a pull request, and it's been implemented since 2019. It's nowhere in the documentation, so I don't know if it's staying or not.
It is staying. I did look at this back in the day, and you're right, it's poorly documented. It wraps around. So this is functionality in Helm file, not in Helm. So Helm file is pulling the secret and passing it as a plain text value to Helm itself. It uses SOAPS, Mozilla's SOPs project, which is the format you've got to follow. So if people are looking for how the format works, you go to the Mozilla SOPs project is usually the best. But yeah, it has had work done to it, like they've expanded the secrets backend. So I don't think it's going away. But yeah, I agree. I don't know why the documentation for Helm file in general actually is quite poor. Though I think they're going to fix it up now that they've moved the project into its own GitHub organization.
And this is another approach that we think will be most beneficial because it completely removes secret handling from CI. And in this case, we are using external secrets, which is a Kubernetes operator that basically has a bunch of CRDs, custom resources in Terraform, in Kubernetes, where it directly connects to Vault and injects the secrets in Kubernetes directly for us. So in this method, we no longer need CI to handle secrets. And there is many different ways of us connecting to Vault, grabbing the secrets, and this is what makes it a good fit, because it's very flexible on how we can connect to it and how we can manipulate the secrets and so on. In this case, for Tanka, we just added, we are generating a secret store, which is basically telling external secrets which provider to look for secrets, and in this case it's Vault. We are giving it the Vault address, which path is going to use, which version of key value backend it uses. V1 doesn't have versioning and V2 has versioning. That's basically the only difference. And then we just tell it how to authenticate, and we will be using its native service account for the namespace with Kubernetes, where it's going to authenticate and the role and the service account it uses. And for external secrets, this is what actually tells external secrets provider where to look for things. So basically, we are telling it to use that secret store we just created, and we are telling it to grab this data, the secret key, a reference, which will be the secret path, and what target it's going to name. This is going to be the secret it is actually going to create.
So there's a secret store. So just trying to clarify here. So there's one secret store CRD per cluster, right? Because we only have one Vault instance per, we have one Vault instance per environment. Each cluster probably only needs one secret store reference. Is that correct?
Depends
Okay.
how we want to scope it. So we
Okay.
can use a cluster one and everybody has access to those secrets, right? But we don't want certain applications to have access to, or potentially have access to other secrets of other applications. So here we are creating one per application.
Oh man, I mean, I understand. I'm just, this all just looks so complicated for what I think is such a simple space. I'm obviously just very focused on simplicity. Like, I don't think we need all this crazy security model, to be perfectly honest. I'm just trying to define, like,
that's the thing. Once this is in place, you don't need to look at it anymore.
yeah,
because the way that you then use secrets, you just create the external secret. Once
yeah.
this
Well,
is
that's what
defined,
I'm trying to understand. Can we move the secret store objects into like the Helm file for Vault? So when you deploy Vault, oh wait, no, that's not going to work. How are you doing it at the moment in, say, staging where you've got like 4 Kubernetes clusters? Do all of the clusters?
so when you deploy the external secrets operator, it does deploy the Vault connection and sets everything. So everything is in place. That's the only thing that you need to deploy in the cluster.
Right. So sorry, so external secrets will be in all 4 clusters, and that's deployed with a GKE service account, which will be the actual process that's authenticating to Vault. And so then we still need a secret, at least one secret store CRD in every cluster, right?
Yeah.
So I guess I'm trying to figure out
cluster wide, or it can be namespace specific.
Okay, so what I'm trying to split here is developers. So our long-term goal in delivery for this year is to get developers owning deployments. You know, like that's one of the things we're moving for. So probably what we want is we don't want, correct me if I'm wrong, we probably don't want secret store objects to live alongside the apps. Like, here's their deployment, here's their service. We don't want them specifying their own secret store, right? Because it sounds like no matter what they say, that they can just say, I'm going to define a secret store that gives me access to everything, right?
Well, you still bound to a role in, like in the configuration in Terraform. You still need to bound that service account to a role that has policies giving access to certain paths.
So, but isn't the service account, isn't the service account external secrets, or is it not? Like the service account?
It's like like the way we did it in the Tenka Eva, every secret store has its own service account created with it. So it's creating a service account that is configured in the secret store, and that's what the secret store uses to authenticate to Vault. So that's how for each app you would have a dedicated service account for accessing the secrets and its own secret store.
So okay, so hang on.
Remember the bound claims I spoke about CI? It also applies here. So for example, here the role is bound to a service account and a namespace.
So I guess the question probably then is, so the external secrets controller, does it do all requests to Vault as itself? Or
no, as a secret store.
Okay, that is the part I'm missing, in which case then that's define, like, I'm just trying to understand, how do we say this app has access to these secrets? Like, we define that somewhere versus a developer just being able to define whatever they want, kind of thing. Is there a split there? We can.
Yeah, with the roles, that's where we define what has access to what, right? And here we set the rules.
Can't they create their own secret store object that has any role they want? Like, that's what or is the role based off the literal Kubernetes service account?
The role is the role has to be involved before.
Yeah. Okay. So basically we're saying that service account for GitLab web can access these secrets, but the actual configuration of the secret store object has no real, like, that's just telling you where to find the secrets and who to find it as, but it's not actually controlling permissions of that. Yeah, I think that makes sense. Yeah. Okay, so yeah, I think the difference is, and maybe this was when I looked at external secrets, and this was years ago, back when it was still under GoDaddy before it was its own project. The model was, I'm not even sure if there was a secret store CRD. It was the external secrets controller runs as the service account, and it just had access to kind of like whatever you wanted. So it was like you had to be careful of what people were setting up as secrets, if it makes sense. But it sounds like they may have fixed that, or maybe not fixed that, but re-architected it so that it now, the controller is still making requests on behalf as the actual user that we expect them to. So there's no way for a user to create CRD objects to gain access to something they're not allowed to access.
No, they can, but cool. they won't get them because what is going to
the external secrets controller will make the request with
the service
saying
account.
Gotcha.
Service account of the app. Yeah. I think it will be easier if I show it here. So for example, we have this one. So this is creating a secret store, an external secret in the Vault namespace. And we can see here that it has been created. And if we go to the secret store, we can see it here. And this is all in the Vault namespace, right?
Yep.
And if we look at the definition, we can see, so it's called Vault, and it's bound to the Kubernetes authentication method.
Yeah, so that's the authentic. Okay, yep.
In this path, and this is basically whatever prefix we give it. We called it Kubernetes.
Yep.
And this is the cluster name. Role it's going to try to use, and if we go back. So I'm pretty familiar with this. So it's saying that. So that's on the secret store object, right? So you're saying I is the secret store. This is the secret store. Log me the service account in this Kubernetes cluster. My web app service account. Log me into Vault at this authentication path, and then you have to specify the role that you're trying to log in as, and then it'll give you access or denied based off, if you actually have access to that role. And the role in Vault was created here. So this is the cluster role, the name,
and that one looks like it's got
and the namespace, and we can give extra policies or not. Here we are not. And then we just specify which service account is going to use. We are using the pre-created one. We could also create a separate one.
Yeah, sure. Yeah. So that means then, each app should have one secret store object and many secret external secret objects on top of that. Cool. Makes sense.
And in terms of secret store, maybe per app doesn't make sense everywhere, right? So we can also make it per namespace or per environment.
Sure. No, I said I was confused. What I thought a secret store object was just basically defining if the whole cluster could kind of access secrets. Now I can understand its request based off the service account itself, then that makes more sense. I think for apps, this is how I see it, and it said this is my opinion, and I'm happy to change it. So there's two kind of layers, right? For the apps upwards, so we can consider the GitLab web app, you can consider like design.gitlab.com, all of the bits and pieces. I think we probably want a secret store per app because their developer groups are going to be they're different people and what they have access to is different. Below that, so like console, Elasticsearch, Fluentd, all those. You could do one per app as well, or you could just have like a global infrastructure one if you really want. Once again, it's up to you guys. I could see it just to try and reduce complexity. You could just have one that you define all of these pieces are part of like the reliability operating group that you could do, but you know, or you could also do one per component as well for maximum security.
Yeah, it will really tie into how we want to structure it in terms of like not having to duplicate secrets, so that we don't have to update them in multiple places and so on, because we can make it as simple as we want or as complicated as we want. Because it's really flexible with the policies. And this is the external secret that it's creating. So he's just pointing to the secret store.
That makes sense.
Yeah.
We will do this. Yeah. We will do this for GitLab Com. So what I'll probably do is when this is all ready to roll, we will just use in our Helm release. Well, we're changing the GitLab Com repo over the coming months, but we will essentially just create pure secret objects and pure external secret objects and just rely on the controller to sync that across. And we won't, because we don't want, I mean, we can all agree, we don't want secrets coming from CI pipelines and stuff anymore. So we'll just do that for the GitLab Com stuff and
much
other
easier to not have to worry about it.
Yeah. We're not going to use the Helm file integration, I don't think.
Yeah, I'll agree that just having the money, because then you don't have to worry about what manifests are being generated, and it's much easier to just put everything.
And also permissions, right? Because like we want, like for us now, it's for everyone on this call who's SREs, like we get permissions to do whatever we want, doesn't matter. But you know, we're trying to move. And actual GitLab developers want to be able to work in the repos a lot more and work in CI pipelines and actually see the CI pipelines, which means we have to get all the permissions and the security out of them.
So that brings up the question, what happens when the Vault server is down?
Yes, I was gonna get to that. And this is what is so great about it. Like, we don't care. Like, it can be down. The only blocker, like you can see Vault being down as the same as like CI being down. Because if Vault is down, then CI probably can't grab the secrets, right? But in this case, we don't really care because the operator syncs the secrets from Vault to native Kubernetes secrets. So if Vault is down, nothing happens. Like, just you won't be able to update secrets, but you can always go and change them directly in Kubernetes until you fix Vault or anything, like same as before, right? Like if JKMS is down, what can you do? Because we are leveraging native Kubernetes secrets. So this is just a way to bring them from Vault and apply them in Kubernetes.
And to be clear, this is only for the external secrets controller. It just syncs them into Kubernetes and then they live in Kubernetes. For the Helm file native integration and for the GitLab CI native integration, if Vault is down, we cannot, like, that means those will not work.
Yeah, we can run the jobs, yes.
Yeah, so one of the things I do want to make sure, actually, I'll wait till the end.
Yeah, all right, so I'll just quickly demo, like, for example, here we have my key with value test true, but if we go to version 1, we can see it's just tests. So if we go to the external secret, I just reduced the refresh interval, but it doesn't really matter. This can be useful in cases where we want to pull stuff dynamically from Vault and update it whatever time. We can just also just disable it, and it will only update when we change the spec of the secret. So here I'll just change it to version 1. Oops. And we go to secret, and we will see the reference that we added there, Vault example secret. So this was created by the operator, and we can see there is a my key with 4 bytes, and there it is, our secret. And if we go back, external secret, we can update it again to version 2. And if we go back, we see that is now test 2. Like, this makes it super easy to just add those manifests with external secrets, and then the operator does everything with the secret.
Can we actually enforce that you can't update a new secret name and get a new secret version? So at least for us, we would really like to basically force that you have to create a new secret object with the new secret version with a secret name like we do now. Simply because, like in the case of the GitLab chart, at least, if you change a secret out underneath it, pods aren't reloaded and everything. And it's like, we like the more deliberate workflow where you have to do a merge request saying GitLab pods, please now use this new secret object, which is a new version of the secret. I'm not saying that workflow definitely necessarily works for everything. Sorry?
Rotate, right? To force the deployment to rotate.
But it's not just that, it's also auditing and stuff like that for GitLab Com. We want to, we if we go into Git, I know you've got the external secret object, I guess, which is kind of maybe that fulfills enough. But yeah, I'm just thinking, is there a way to have like, you make the external secret, sorry, the external secret object immutable, or like you can't update it, you need to create a new one?
Unsure.
That's fine.
There is
That's okay.
lifecycle ownership.
You know what? That's fine. We can do that. We're going to start doing static analysis tests on manifests anyway. So that's something we can pick up in there. And then we can just be like, we would, we fail a test saying we don't want you to do this if that's
because there is like policies for like when does it delete a secret or not and stuff like
sure,
that.
That's fine.
But I think stuff like that is probably better addressed with ALPA or something similar.
I think what we want to do is just like static analysis at CI time, right? So that way we can give feedback to the user, this has failed and this is why, or define a library, even if it's running Opera underneath or something, like a just Opera standalone to validate that. That makes sense. Cool.
Yeah, I haven't looked in detail what it can do in that aspect, but there is policies at the operator level. Maybe it can do that, but yeah, certainly something that we can check. And just to wrap up, in other use cases, for example, what we would do for Shelf, there is an official Vault Ruby library, so we can do the same thing as we currently do with JKMS, where we just source the secrets from an external library. Same thing for Ansible. There is a community module where we can use the same kind of authentication methods we use here, like native GCP and so on, so that we don't have to rely on static service account keys. Like, for example, these will all rely on IAM, so that we don't have to have manual tokens. Well, we don't want to have secrets to access secrets. We want them to use IAM and stuff that we already have in place.
Have you guys looked at what Devin did? Like, Devin, you could almost got the whole way with the Chef Vault stuff, didn't you?
Yeah.
Is it still around? Like, I don't think we deleted it. Right?
The code's still there, and I don't remember exactly where it is. It's been a while, but it's all still uploaded.
That would be useful. Nice.
Yeah, I can help you find it if you want.
Yeah, thanks. Yeah, we haven't looked much in detail into Chef or Ansible yet, just because we know that it's possible to do and there is many ways to do it. But probably the least resistance way will just be to do what we currently do with JKMS, just using an external library or something like that.
I've used the Ansible one before, so yeah, it works.
And then for last, group policy, so that we can give people access, it's in progress. We are waiting for IT in an access request to give us some credentials so that we can authenticate with G Suite to get access to group membership.
Are you doing anything with the Vault agent?
No.
So one of the things that I found when I was looking at the chef stuff is that there are cases where we don't want to wait for the next chef run to update secrets. Console and databases and stuff like that were the main ones, but I think there were some others. So the solution that I was using was with Chef, install Vault Agent and then let Vault Agent update the local config files on all the pets. It was a nice way to make sure that when you updated Vault, it immediately updated all of the config files in places where we're running off the secret that's in a config file.
Yeah, definitely possible. It's also nice because the Vault agent actually caches certain things. So even if Vault is down, there is still some caching there.
Well, and if you use Vault agent to write to a local config file for a service that's only going to read from a config file that doesn't know about Vault, once it writes to the config file, it's there. So it's kind of built-in caching.
Yeah. Like we are trying to deliberately not use it as let's say a dependency of runtime. Like that's why we have this approach with external secrets because you can use Vault agent also in Kubernetes and the application will read directly from the Vault agent. But we don't want to have a hard dependency on Vault as a tool. Like it does, like if Vault goes down, it should not affect any of our production services, right? We haven't looked into using the agent for Chef or anything VMs yet, but yeah, it'll be nice to have. But for now, we are just looking at like replacing.
Yeah, I think I have an existing recipe in Chef to install Vault agent and to get it writing to an arbitrary file. But yeah, I remember that same thing. I didn't want to use Vault agent for authentication, but using it to do its templating thing, like the console templating, where you just say, when this value changes in Vault, change it in this file, and then let the application use the files. That way you didn't have that dependency that Vault has to be running all the time.
Yeah, it does. Integrates with console also, so we can use both. Definitely, lots of possibilities. We're just trying at the moment just the basics, so that we can at least start using a single source of truth for the secrets.
Yeah, it's long overdue.
Yep, and that was all that I had to show. There is lots more things that I didn't get into because it will get too long. But from the document links, there is links to source code and more documentation and so on if you're interested in exploring.
So this is currently just deployed in pre, is that correct?
Yes.
Have you started talking to the security team yet at all about the architecture? Okay, cool.
So yet. That will be next steps.
Yeah, cool. I suggest do that sooner rather than later, because the big thing that jumps out at me, and once again, things may have changed, I'm not sure, is the difference in deployment model versus when we were looking at this last time. So last time we did an isolated GKE cluster that was completely internal and not accessible from the internet because it is our secrets. Looking now, like vault.pre.gitlab.net, what are you using for ingress, or like what is confronting that to the internet? Is it just an external load balancer, or?
Yep, just the external one using
some
So
GCP load balancer.
But is it a GKE ingress object or just literally service type load balancer?
Both. The external one uses GCP with IAP at the identity aware proxy stuff so that we can access the web page UI outside of the internal network, right?
Okay, yeah.
So that one doesn't work for anything CLI or API related directly. So we have the internal endpoint, which is just a service using
type load balancer, type internal. Yeah, okay, cool. That So hang on. So if I go to vault.pre.gitlab.net, is that through IIP?
Yeah.
Okay.
Yeah, and then there is
Okay, cool. Yeah, I see. Yeah.
endpoint, which is the internal
That's
one
not restricted to our org, isn't it? Because I just tried that logging in with my personal account and the screen came up. Or unless, no, it must be. Okay, I must be have my browser configured wrong. That's fine. That's perfect. That's what I was just wanted to check, because anything we expose to the internet, obviously we need, basically we don't just want to trust on Vault itself, not having like permission, you know,
Yep.
like a security bug before we expose it to the internet. IIP is perfect. So that means we're planning on running a Vault cluster per environment. So one in pre, one in staging, one in production, instead of like an isolated one with namespaces, or we haven't got that far
No.
in thinking about that yet.
We would prefer to just run one for production as a whole.
And one for non-production.
Yeah.
Okay. Yep. Yeah, that's what we did before. So that makes sense.
Yeah, so that we have like a staging cluster and a production one. Yeah.
Someone can refresh my memory. Is our Terraform repo public?
No, it's not.
Okay, cool.
No, it's
Because I was going to
not.
say the last time security pulled, one of the things security wanted is like all of the roles and permissions, which is all in Terraform. We actually, correct me if I'm wrong, Devin, we didn't do this in the GitLab com repo, didn't we? We had like an entirely separate repo that was like,
Separate, yeah.
yeah. So I think it's probably fine because the GitLab com Terraform repo, or whatever it's called now, config management, it's not public. But once again, security will let you know if they want it even further locked down. So all I'm saying is you may end up having to pull that out into its own Git repo, but I'm hoping not, as long as it's not public. Oh, and you know what? The thing with security is it depends who you get. The team themselves may have changed their mind on what they want to do with that. So, and I think that was pretty much all I had. So yeah, the other thing, so the external secrets, so there's two interfaces for us in delivery and probably the developer users eventually are going to be using, right? So I'm going to try and push them for Kubernetes just to using the external secrets controller, because it is a simplistic model and because they can just generate their own manifests, and it sounds like the permissions we can handle reliability side, and there's just no way they can really screw it up or make CI pipelines fail. I don't mind, you know, if people want to use the Helm file integration, but I think just pushing for generic secret objects and external secrets will just be much less painful for everyone. The other big one is going to be secrets in GitLab pipelines. So classic example will be the release tools pipelines and the GitLab org GitLab project pipelines. So that's where if Vault is down, the CI pipelines won't work, and that can be a huge risk for us in delivery, especially if we're close to the 22nd of the month. And like, it's not even Vault being down for a few hours or a day can cost us a lot of time when we're trying to meet deadlines. So the only thing I think it'd be good some point in the project is to consider, I know you've tested backups. Can we do automatic backup retesting? So like, you know how we do with the database, we have a CI job that like spins up a new Vault cluster, restores the backup every day. So it's like, we're all constantly testing the backups. We should try and make sure we're doing that. With the open source version, do we get streaming replication? Can we actually have a cluster running somewhere else and we stream replication to it or not? Okay.
No, that's enterprise.
Yeah, enterprise. Yeah, fair enough. Okay.
We can kind of doing it based on the snapshots, right? Because you can just have the snapshots restored automatically. But yeah, no.
Maybe that's not a bad idea. Or the other thing is, it'd be great, maybe this is too hard, a runbook or a script where, so GitLab CI's integration, it just populates environment variables, right? So at the moment in a lot of our important pipelines, in the GitLab application, right, we just go in, in the CI CD settings, we're like, here's an environment variable, here's the value, mark it as protected, and all that kind of stuff. And so what we'd be doing is removing those by the sounds of it and putting them into Vault. And the end result is the same, whether they're environment variables coming from GitLab or whether they're coming from Vault. It would be good to have an emergency runbook and or tooling or script where we could be like, gets all the secrets for a specific CI job and actually uses the GitLab API to populate them back in as GitLab secrets. So it's kind of like turning off the Vault integration. Like if Vault's down or it's having problems and we are like, we need to run pipelines now, like an easy runbook that's like, take a backup, restore it, click this button, and it just populates them over in the CI/CD settings. And then, we can run pipelines. And then when we fix things, we just go through and delete them all and switch it back to Vault. Or it doesn't have to be that extensive. And maybe the backup restoration process is just something where we've got a clear, in case of emergency, and there's like lots of stress, we've got to have a clear understanding of if Vault is down and we're not sure when we can get it back up, there's a way that we can just get the secrets we need into environment variables on like ops.gitlab.net, and the GitLab project might be the big ones. We can identify a list and be like, we can just get them running manually somehow until things like calm down. Hopefully we'll never need it, but I think that would be really good just to get that confidence in the CI/CD integration, because at the moment, it comes from the like ops.gitlab.net. They just stored an ops.gitlab.net. If ops is running, the CI pipelines are running, it's all fine. It's a closed system. So if we're introducing an external dependency, just once again, having a runbook or a process where we can kind of flick it back just temporarily if needed would be good.
A snapshot restore is a two-step process. So
That's
two
fine.
commands, and that's
yep.
You just need access to KMS. As long as you've got access to KMS, you can auto-install and you can restore.
So when we were looking at this last time, we talked to some other groups that were using Vault, especially the open source version. They had a bug where they had, not only did their Vault instance go down with corruption, but their backups for a week since they upgraded Vault were also corrupted. So I'm not trying to cover every scenario, because that was obviously a very specific and rare scenario. But I think, once again, just in case the Vault ecosystem has something wrong, what would be the options there, considering these are just environment variables we can populate?
Yeah, the snapshot is a Kubernetes job, so we can make it run as often as we want.
I do think just like trying to keep like, I know we don't get streaming replication, but even just like a master that we just have a job that's kind of manually syncing it, because most of the time secrets won't change, so it's not a big deal. It's more about availability. Some kind of hack we can do to try and keep some secondary availability, I think could be nice. Like that might be good enough. You could consider doing something like an export to plain text or something, and then GPG encrypting that as well and putting it in a GCS bucket. Maybe that's overkill. I don't know. It's just thinking about different ways to really build that confidence, so that in an absolute failure, in a failure scenario, we have a clear understanding of how we need to get those things so we can keep moving. I think that's the key takeaway. But I think if we can just make sure we keep I would be just fine with like a secondary one running in US West, maybe, and then like once an hour, half a day, we just like snapshot restore, and obviously paging the OCs if that doesn't work and things like that. That's probably just good enough. And then making sure, and even in delivery, we do rollback tests. It's not unreasonable for us to do a test once a month or whatever of testing the secondary Vault instance. We can do that as part of like standard monthly disaster recovery testing.
Yeah, I mean the backup snapshot and restore stuff is quite small in size, so we can really do it like hourly or anytime.
Yeah, that's fine. Just something like that. I think really just to make the confidence, so that those we don't, in the case of the Vault being down and we actually really do need to run CI pipelines. It's not something that needs discussion. There's just a runbook. Like this is exactly what you need to do. Boom, change it over to this. And just away you go, so that delivery and everyone else can just easily follow that. I think that's the key.
Yeah, for cases like CI variables and stuff like we already have in place, I was thinking of just like leaving both running.
Sure.
As
yeah. We're not just going to cut them over tomorrow. Yeah. I think the thing is probably what needs to be done as well, and this isn't really reliability's job. Is probably an audit needs to be done on some of them. I'm not sure if we need all of them. There's probably a lot that, because the ones we add into the UI, they're not in Git. We have no Git history. We don't know who added them, when, or whatever. So at the risk of making this project take longer, but at some point, someone's probably going to need to, when we move them, probably audit them. It could be good to get security involved. They've got infrastructure security now, and like say, hey, look, we're moving all these over. and then get them to like document where they are, where they're coming from, who's using them and stuff like that. Like it could be some joint work you could do there. But yeah, that makes sense.
Yeah, that would be nice. Yeah.
Have we thought yet about, it's probably too early to really think about, like, it's fine. I was just thinking, like, do we actually just want all secrets to be created by reliability, or do we want end users to be able to create them? But I guess it might depend on per application, I guess.
Yeah, I think for now we are growing with the same model as before.
Yeah, so just tickets to reliability to create it, and then yeah, cool. It makes sense.
Same groups that we currently have in GCP that can access GKMS and so on.
Yeah, that makes sense.
One thing we did at the previous company is reliability had full access to secrets and stuff, like we could view, create, delete, and everything. And the developers had access to their group, and they could create secrets. So if they had access to a secret, they could create it. And I'm not sure if they could update it or not, but they could not delete and they could not view secrets. So they only knew the ones they were creating or updating. And yeah, they could not delete or view anything.
So by creating, it's like if I create a secret, that creates the secret object, but then what populates it with something random?
No, I mean that they can inject the secret. They can see what secret
but then they can't change it,
right?
okay.
But other people and themselves, then after they create it, they cannot read it.
You can never see it. Yeah, fair enough.
Yeah,
oh, delete it.
Yeah, it was a bit too much because there was always cases where people wanted to confirm what was there.
Yeah, so they're asking. Yeah, right.
But yeah, definitely possible. Yeah.
I think ultimately that probably will be driven once again. I think, security should weigh in a lot on how we want to do that, possibly.
Yeah, at least will give us way more possibilities than we currently have with JKMS and stuff on how we want to go forward in restricting access and all of that. Yeah, it's nice. We are a bit over time, but thanks everybody for joining. And glad that there was a good discussion, and thank you.
See you.
Thanks. Bye.
Yeah.